Legalett has supplied air-heated floors and frost-protected shallow foundation systems worldwide since the 1970s. The first installation in North America was in 1988 in Peterborough, Ontario, Canada. The Legalett air-heated floor and foundation system provides superior comfort, decreases construction time and labor costs, uses state-of-the-art technology, has the ability to control indoor air quality and moisture, saves energy, and is good for the environment. What is an air-heated floor? An air-heated floor is a simple concept. The Legalett system circulates warm air through a network of air piping cast into the slab. Air is the energy transport medium only. The slab provides a large thermal mass for heat storage and delivery to the building. The Legalett way includes the following phases. Project start and definition phase, driven by the developer, architect, or homeowner. Application engineering, pre-sales technical support, and costing phase, performed by the installer, supported by the Legalett service rep and Legalett engineers. Design and drawing production and building permitting to meet the building schedule. Materials shipped to the site. The installation package arrives on site. Installation phase completed by a Legalett installer. Construction technical support provided by the Legalett service representative and Legalett engineers. Quality assurance inspection. Customer satisfaction is paramount. Legalett provides after-sales service through its network of service reps and provides an online parts catalog. Legalett is a building system. We follow the building process from concept to move-in. We design both the foundation and the heating system as a whole. Each slab is custom designed for heating requirements, moisture control, and frost heave. Legalett takes a conservative approach to design, using robust and common building materials. Control systems are simple and easy to install and use. All Legalett installers are trained both in the classroom and in the field. Inspections are required at the pre-pour and system startup stages. The Legalett system is covered by a 7-year structural and 2-year mechanical warranty. This 4-story Legalett home is over 10,000 square feet and is located north of Toronto, Ontario, Canada. This 2-story waterfront home is over 3,000 square feet and is located in eastern Ontario, Canada. This 1,800 square foot log home is one of many Legalett homes built in a recreational subdivision near Mont-Tremblant, Quebec, Canada. Legalett is suitable for all types of construction, including residential homes, townhouses, schools, daycares, assembly buildings, commercial and industrial buildings. Indoor temperature stratification differs with each type of heating system. Legalett system closely matches the ideal indoor temperature distribution. Heating with forced air provides an inverse temperature distribution. With forced air heating, energy is wasted since the warmest air is at the ceiling. With Legalett, the warmest air is near the floor and the coolest air is near the ceiling, increasing comfort and energy savings. The natural way is to heat from the floor and cool from the ceiling. Water and electric heating units are available. The water heating unit can be supplied with hot water from any natural gas, propane, oil, wood, geothermal, or solar water heater or boiler. With its high thermal mass, the Legalett system can take full advantage of multi-tiered utility rate structures. When heating with Legalett, you are immediately warm once an outside door is closed in the winter. You do not have to wait for the furnace to heat up the air for you to feel warm again. The 2-inch piping system is typically used in residential construction. The 4-inch piping system is typically used in commercial industrial construction or where additional thermal mass is desired. Piping density in the slab is varied for optimal performance. Higher densities can be used in bathroom areas, and lower densities can be used in bedroom areas for optimal comfort. Room-by-room energy balance and zone control is possible. Up to 60 watts per square meter or 20 BTUs per hour per square foot is available. Up to 4 zones per 1,600 square feet is available. During power outages, a homeowner can rely on the superior thermal mass of a Legalett foundation. Indoor temperatures typically drop just 1 Celsius over 12 hours with Legalett's 5-inch slab. This temperature reduction rate will decrease over time as the interior temperature lowers and the temperature difference decreases between indoors and outdoors. The 2-inch heater box is cast into the slab flush with the floor surface. The heating insert fits neatly inside the heater box, accessible and simple. The 8-inch slab typically loses just 1 Celsius over 24 hours, the ultimate in heat storage and thermal mass. There are 3 main reasons why Legalett saves energy when compared to traditional heating methods. Legalett provides superior under-slab insulation. In a Legalett home, the room temperature can be reduced while maintaining comfort. In a Legalett home, the temperature at the ceiling is cooler, reducing heat loss. At the design condition. For a typical home located in Eastern Ontario, Canada, the temperature drop across the ceiling decreases by 6 degrees Celsius for a reduction of 14.1% in heat loss. The temperature drop across the walls, windows, and doors, as well as the infiltration temperature drop all decrease by 3 degrees Celsius for a reduction of 6.7% in heat loss. There is a net heat loss decrease of 9.6% through the R24 slab. This amounts to an 8.3% net reduction in total heat loss at the design condition when compared to conventional forced air heating systems. Energy savings increase as the outdoor temperature rises above the design condition. Consider the entire heating season. With Legalett, the comfort temperature set point in the building can be lowered, reducing the number of days requiring heat and reducing the amount of heat required each day. For example, Environment Canada weather data for Cornwall, Ontario shows that there are approximately 4,200 degree days below 18 degrees Celsius and 3,400 degree days below 15 degrees Celsius. A drop in indoor temperature of 3 degrees Celsius with Legalett results in a savings over the entire heating season of 19%. Legalett performs individual heat loss calculations for each building, considering conduction and infiltration at 0.12 ACH. Building ventilation requirements vary from region to region and with building type. Ventilation must be accounted for by the mechanical system designer for any makeup heat requirements. Legalett in-house comprehensive engineering protocols ensure quality and commitment to each customer. Legalett evaluates each building for optimum piping lengths and density, piping insulation requirements, insulative floor covering influences, and inlet water temperature for water coil heaters. Pipe loops are insulated to drive the energy to the perimeter of the slab. Typically, full insulation is used for the first few meters, and then half insulation is used for the next few meters. This graph represents the floor surface temperature and heat flux to a room above a pipe loop in the floor, along the length of the loop. State-of-the-art finite element modeling for heat transfer is used by Legalett engineers. Legalett is designed in accordance with the National Building Code of Canada and the International Residential Code. EPS is governed by the American Society of Testing Materials by the Canadian Standard Association. Legalett lies gently on the land. Legalett's design is based on a soil loading of 75 kilopascals or 1,500 pounds per square foot. with the possibility of reducing 17 kilopascals or 350 pounds per square foot in problem soils with little change in design and costs. Legalett can even design for zero loading with its compensated foundation. This means that the land does not see a resultant load. Ask about our zero load design for bog or permafrost applications. Legalett engineers analyze slab loading. Reinforcing is determined. Maximum deformations are reviewed. Shear is analyzed. And finally, resultant bearing is reviewed. With 4 inches of clear stone and 6 inches of EPS, the Legalett system provides a capillary break to prevent moisture from migrating to the slab from the soil during the summer months. Heating the slab eliminates the conditions for mold and mildew growth. Water and melting snow dry up quickly, eliminating slippery floors. The Legalett construction heater is used to provide heat to the building during construction and remove moisture in the slab prior to the installation of floor coverings and the permanent heater insert. Moisture is present in 2 phases in concrete, in a liquid and a vapor phase. A moisture meter only measures moisture in the vapor phase. The higher the temperature of the slab, the more liquid water changes phase to water vapor and is then driven off. The slab temperature is ideally elevated to 28 to 30 degrees Celsius with the construction heater during the drying period. The construction heater can extend the construction season into early winter by putting heat into the slab immediately after the pour. Legalett provides a minimum of 6 inches of EPS below the slab, thereby maintaining the efficiency of the heating system even with insulative floor coverings. Frost-protected shallow foundations, or FPSFs, are alternatives to deeper and more costly conventional foundations that are used in regions that experience seasonal ground freezing and the potential for frost heave. FPSF design allows footings to be founded above the traditional design frost depth by insulating the foundation and ground in a manner that prevents frost heave. In the Nordic countries, well over 1 million FPSFs have been constructed successfully over the last 45 years. In Scandinavia, the FPSF is commonly used on both residential and commercial buildings, such as houses, townhouses, apartments, shopping malls, schools, low-rise office buildings, restaurants, gas stations, and so on. FPSFs have been the standard practice since the 1970s. The earliest documented use of the FPSF concept in the United States was by Frank Lloyd Wright in the 1930s. In 1994, the U.S. Department of Housing and Urban Development conducted several demonstration and monitoring projects to verify the performance of existing European design practices. As a result, an FPSF design guide was developed to serve as a basis for building code acceptance and standardization in the States by the National American Home Builders Research Center. The International Organization for Standardization is a worldwide federation of national standards bodies that have developed a number of standards for FPSF designs. Section R403.3, Frost-Protected Shallow Foundations, is contained in the 2006 International Residential Code, published by the International Code Commission. Standard 32-01, published by the American Society of Civil Engineers, covers the design of construction of frost-protected shallow foundations. What is frost heave? Frost penetration into the ground does not mean there will be frost heave. The volume increase that occurs when water changes to ice was at first thought to be the cause of frost heave. But it is now recognized that the phenomenon known as ice segregation is the basic mechanism. Water is drawn from unfrozen soil to the freezing zone, where it attaches to form layers of ice, forcing soil particles apart and causing the soil surface to heave. For frost action to occur, 3 basic conditions must be satisfied. The soil must be frost susceptible. water must be available in sufficient quantities, and cooling conditions must cause soil and water to freeze. If one of these conditions can be eliminated, then frost heaving will not occur. Water must be available in the unfrozen soil for movement to the freezing plane, where the growth of ice lenses occur. A high groundwater table with respect to the location of the ice lenses will therefore favor frost action. Where proper drainage is prescribed, water can be prevented from reaching the freezing zone in frost-susceptible soils. What is a frost-susceptible soil? Even though water is available, significant frost heave will not occur unless the soil can draw the water up and hold it in the freezing zone. Soils which are capable of this are called frost-susceptible. Frost susceptibility is related to size and distribution of soil particles. In general, coarse-grained soils such as sands and gravels do not heave, whereas clays, silts, and very fine sands will support the growth of ice lenses even when present in small proportions in coarse soils. If frost-susceptible soils located where they will affect foundations can be removed and replaced by coarser material, frost heaving will not occur. This chart classifies 4 groups of frost-susceptible soils. The Air Freezing Index, or AFI, is a measure of the severity of winter, or the number of degree days below 0 degrees Celsius during 1 year. For design purposes, Legalett uses the 100-year return AFI. This represents the worst winter in 100 years. Weather data is compiled for all locations in North America and is used as a basis for finite element computer simulation modeling of the frost line. All simulation periods are 2 years, with the worst winter in 100 years occurring in the 2nd year. To understand frost heave, we need to understand the geothermal properties of the Earth's surface. The mean annual ground temperature is greater than the mean annual air temperature, primarily due to the insulating effect of snow and ground cover. During the winter months, FPSFs rely on trapped energy imparted to the ground during the summer months. As a rule of thumb, the mean annual ground temperature increases 1 degree Celsius for every 50 meters of ground depth due to geothermal heat. As an example, in Ottawa, Ontario, Canada, the mean annual ground temperature is 9 degrees Celsius and the mean annual air temperature is 6.3 degrees Celsius. This diagram illustrates the relationship between air, surface, and ground temperatures on an annual basis. The depth of freezing is largely determined by the rate of heat loss from the soil surface. Besides the thermal properties of the soil, this heat loss depends upon such climatic variables as solar radiation, snow cover, wind, and air temperature, the last of which is the most significant. If the rate of heat loss from the soil can be reduced, frost-susceptible soils may not experience freezing temperatures. Legalett undertakes a conservative approach to predicting the frost line. The heat absorbed by the soil during freezing, or latent heat, and the heat capacity of the soil increase with the amount of water present in the soil. Thus, the more water present in the soil, the more the soil is resistant to freezing. For simulation purposes, sufficient moisture must be available to allow frost heave, but not so much as to cause the soil itself to resist the penetration of the frost line. A coarse-grained soil, or non-frost susceptible soil, which is low in moisture, will freeze faster and deeper, but with no potential for frost heave. This diagram illustrates ground temperature contours in Ottawa, Ontario, Canada, during the most severe winter in 100 years. In addition to air-heated floors, Legalett supplies unheated slabs for heated buildings and unheated slabs for unheated buildings. The installation of a Legalett slab is simple and cost-effective. Strip organic material. Place clear stone. Rough in electrical and plumbing. Place edge element. Place EPS. Place heater box. Install wire mesh, piping, and piping insulation. Pour and finish concrete. Run construction heater. And finally, install the heating units and thermostats. Heater cover finishes. The heater box can be placed almost anywhere on the floor and finished with linoleum, carpet, ceramic tile, or wood. It is preferable to locate the heater in a central location, but not required. The heater box cover is a high-density fiberboard material that floor coverings can be installed on. Generally, the heater box is located in a closet or other non-traffic area so that cover leveling and sealing is not necessary. If the heater box is in an exposed location, the following procedure can be followed. Place a small plastic sheet over the heater box inner cover. Install outer cover and verify the cover is at or below the concrete surface. The plastic sheet allows for easy removal in the future. Apply a bead of latex caulking to perimeter of outer lid, install, and level. Trim excess plastic and install backer rod around the cover perimeter. Install flexible caulking between lid and concrete to seal. And install desired floor covering. Legalett reduces construction times. Legalett saves labor costs by making the construction site more manageable with easy access for delivery and assembly of materials and equipment. Concrete is delivered only once to site since there are no separate pours for footings, foundation wall, or floors. Late season pours are possible at no additional cost for winter construction with the Legalett construction heater. The foundation is ready to be built on 2 days after the pour. No backfilling is necessary. Only 7 man-hours per 100 square feet are required, usually consisting of 1 journeyman and 2 to 3 laborers. This includes labor for stone raking and leveling, EPS, wire mesh and piping placement, ready for concrete pour. This assumes that a dozer is available for excavation of topsoil and a stone slinger, dozer, or shovel is available for stone placement. An experienced installer can reduce this to 5 man-hours per 100 square feet. Electrical and plumbing rough-in are not included. A 2-inch system ready for pour. Pouring concrete for a 2-inch system. Let's review the Legalett advantages that we have discussed. Superior comfort. Lower capital costs. Lower operating costs. Ability to build on poor soils. Prolonged construction season. Elimination of mold and mildew. Heat during power outages. Legalett provides for many other advantages as well. Easy to provide heated garage. Easy to add cold porches. Ideal for physically challenged. No water leaks. Simple controls. Low maintenance costs. Legalett is healthy for the environment. No effect on groundwater. Does not kill mature trees. Can use passive solar energy. Reduces energy requirements. Uses people-friendly materials. Enjoy a few samples of Legalett buildings. Thank you for allowing us to share the Legalett way.